All right, so the questions that you guys asked me to go through are questions 5, 6, and 7. For 5 and 6, I'm going to do each one in a different way to show you the different ways that you can go ahead and graph these. So for this, when we're solving systems of equations, remember we just graph them individually. So I'm going to first graph x minus y is equal to 3. And for the first method is I'm going to rearrange them. We're used to graphing them in y is equal to mx plus b. So if it's not set equal to y, then I'm not able to look at this and say, oh, this is my y-intercept. It needs to be set equal to y. So I'm first going to rearrange this. So it's x minus y is equal to 3. So even though I don't see the plus sign, it's a positive x. And since these are separated into separate terms, I know that this x is being added. So I need to subtract x to start getting y all by itself. So don't forget, though, it's negative y. So it's negative y is equal to negative x plus 3. And our equation is y by itself positive. So I need to get this as a positive y. So every single term needs to be divided by negative 1. And don't forget, everything needs to be divided by that. So it becomes y is equal to, well, negative x over negative 1 is a positive x. Positive 3 over negative 1 is negative 3. So now this is in y equals mx plus b form, where my m is a number in front of my variable x, so it's 1. And my b is negative 3, so it's the point 0, negative 3. So I will then go ahead and plot the point 0, negative 3. And then I'm going up 1 over 1, up 1 over 1, up 1 over 1. Now make sure you use a straight edge on your test. I can't really use a straight edge when I'm using this device. So I'm just going to put as many points as I can just so I can kind of know exactly where the answer is. All right, so that was our first one. Our second one is 7x minus y is equal to negative 3. So I'll do this graph in blue. So same thing, we need to isolate our y. So since these are separated into different terms and it's a positive 7x, I'm going to subtract 7x. So remember, it's negative y, so we have to remember to keep that negative with it. So negative y is equal to negative 7x minus 3. And now I'm going to go ahead and divide each term by that negative 1, so I can write it as a positive y. So y is equal to, well, negative divided by negative is positive, and negative divided by negative is positive as well. So it's positive 3. And then our slope is a positive 7. So remember, our slope is 7 and over 1, and our b is equal to 0, 3. So I'm going down 1, 2, 3, 4, 5, 6, 7 over 1, 1, 2, 3, 4, 5, 6, 7 over 1, up 7, 1, 2, 3, 4, 5, 6, 7 over 1. So I'm just putting as many points since I don't have a straight edge for me to make sure I'm connecting them properly. You will use a straight edge on your test, otherwise your answer will be slightly off. So this is where they share. This point is where they overlap. That is negative 1 for x. So our answer is negative 1. And down 4 for y. So negative 1, negative 4 would be our answer. All right, so for number 6, I'm going to graph this first one, y equals 2/3 x plus 4. This is already in y equals mx plus b form, so we can just identify our slope as 2/3, and our y-intercept is 4, so the point 0, 4. So I'll go ahead and plot that point, go up 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3. All right, so I'm just putting as many points as I can because when we are using a graph, having those exact points will just allow us to see where they intersect a little bit better. And since I don't have a straight edge or can't use a straight edge on this device, it just makes it easier for me to graph. All right, so everyone should be able to do that one pretty easily. So now we have 4x minus 6y is equal to negative 24. We could rearrange this if we wanted to, but just to practice different methods, since this is in standard form, we are going to use our intercepts. All right, and the reason why I am using the intercept on this one and not the other is 24 is divisible by both 4 and 6. If 24 isn't divisible by both, then I might just rearrange it because then we're going to have a decimal or fraction that we're going to be using and approximating where it's at on the x or y intercept. So since I see that both of these are divisible into 24, I'm just going to use my intercepts. So we will solve our x-intercept. And remember, that's where we cross this x-axis. So this line here is our x-intercept. And our y value at that point, on any point on this x-axis line, we never moved up or down from the origin, so our y value is 0. So the way that we can graph this is we set y equal to 0, and that will tell us what our x-intercept is. So 4x minus 6 times 0 is equal to negative 24. Well, 4x is equal to negative 24. We divide each side by 4, so x is equal to negative 6. So our x-intercept is the point of negative 6, 0. And we know that that's true because at our intercepts, the other variable is 0. So at negative 6, 0, I'll plot the point. Well, I already know my answer just from that point alone. And then I'm going to go ahead and move this over, and let's go ahead and do our y-intercept. Well, our y-intercept, we should already know this one. That's this line, and we already know why we write our points like this every time is so that we see, okay, at our y-intercept, our x is 0. So that means I'm just going to set x equal to 0. So 4 times 0 minus 6y is equal to negative 24. Well, this is going to be 0. Don't forget it's minus 6y, though, so don't mess that up. Is equal to negative 24. We divide each side by negative 6. Y is then equal to 4, so it's the point of 0, 4. 0, 4. Okay, now when I plot those 2 points, I'm going to go ahead and draw my graph. And if you see here, now that we graph this, it's a good thing I didn't say, well, we didn't exactly know the answer when I said that earlier. But now we see that those 2 lines fall exactly on top of each other. And remember, when they are the same line, they share every single answer that one has, the other has as well, because they're directly on top of each other. So our answer for this is infinitely many. So any one that's a solution to the red graph would also be a solution to the blue graph because we see that they are the exact same line. All right, one more question. All right, so for this one, I put this on because the answer is a fraction or decimal. So we are going to be approximating. So m is equal to 3 over 2. B is equal to 5, or the 0.05. So we'll go ahead and do 5. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. 1, 2, 3, 1, 2, 1, 2, 3, 1, 2, 1, 2, 3, 1, 2. All right. Once again, you don't need to do all these, but because I'm not able to use a straight edge on this, I am just putting as many points as possible. All right. So there's the red graph, the blue one. Y is equal to negative 9/2 x plus 9. Well, our slope is equal to negative 9/2. Our b is equal to 9, so it's a point of 0, 9. So it's up here. And now I'm going down 9 and over 2 and down 9 and over 2. So there's those points. So now I'm going to draw the line connecting these. All right. Now you can see my lines are not perfectly straight at all. So my answers might be different than what it is on the answer key. But now we're just approximating what this is. All right. So when you do this, if whatever if you have to approximate at any point, I would expect it to be what your graph shows. So if this is their point of intersection, that to me is almost at 1, because you see the point of intersection is maybe right here. So based on my graph, I'm going to say it's 0.8. And then here it's maybe a little bit more than 6. So I'll say 6.75. All right, so you see I'm actually using my graph's answer. If my line was perfectly straight, it might be a different answer in this. As long as if your graphs are drawn, yours will be straight. But as long as your graphs are drawn accurately, however you're interpreting that point, as long as it's in the ballpark, then that will be fine. All right, that is it for this video.